If you go ahead and look at page 433 in your book, it'll have a good summary of what we were just referring to with the different graphs of our six trig functions. Now, let's go ahead and take a look at this. We have a certain angle that goes to a point xy. So we have our angle t, whether you think of t as being your angle here or the length of your curved arc on your unit circle does not really make a difference. So, what happens if we have any of these other situations? Instead of going clock or counterclockwise t, let's go counterclockwise t, which would be our negative t. Our negative t is going to be the same distance to the right, but instead of going up, you're going down. So we get the point x comma negative y. If we look at t and then go backwards pi, that means go to here and then go backwards pi, which is a half a revolution that puts us back over here. Which would really be the same thing as this one here, being at t and then going forwards a half a revolution. In either case, instead of going right and up, we go left and down, so it's a negative x, negative y for each one of these. What happens if we have pi and we go backwards t? So you're at pi and you go this curved distance, you go that far backwards. Or another way to look at it is if you're at negative t for this one here and then go backwards pi. So you're at negative t and then you go backwards your half a revolution. Either one puts you up here. You're left and up, so it'd be negative x and y for both of these. So let's go ahead and take a look at these negative formulas. If you're looking at the sine of negative t, that would be here. The sine is your y coordinate. How does that compare to the y coordinate of the sine of t? Because we want to compare the sine of t to the sine of negative t. Well, how do these two y coordinates compare? They're really opposites of each other. So we're not going to say they're equal, we're going to say they're opposite, and that's why I have the negative here. Let's also take a look at the cosine of t and cosine of negative t. How do these compare to each other? Well, cosine of negative t, here's your x-coordinate. How does that compare to the x-coordinate, which would be the cosine of t? Well, you're both the same distance to the right, so they're going to be equal. Your secant, which is the reciprocal of sine, is going to follow the exact same sign or pattern as sine. So it would be the opposite of the secant of t. Cosecant of t, I mean. The secant of negative t is the reciprocal of cosine. So it's going to follow the same pattern as cosine did, and they'd be equal. Our tangent and our cotangent. Our tangent of t and negative t, here we have the tangent of negative t. It'd be your y over your x. Tangent of positive t would be your y over your x. But you notice this would be y over x, this would be negative y over x, so they're really opposite of each other. So we're going to say it's the opposite of the tangent of t. Your cotangent of negative t is going to follow its reciprocal function of tangent. So it would be the opposite. So we're going to go ahead and simplify this. Well, we were just looking at the cotangent of negative x. We just said that that's simplified to the opposite of the cotangent of x. Your cosine of negative x, we just said simplified down to being the same as the cosine of positive x. The sine of negative x, we had just said simplified down to be the opposite of the sine of x. Well, cosine is really cosine, or cotangent is really cosine over sine, multiplied by your cosine minus your sine. This is really over 1 here, so we're multiplying these two fractions together. When you multiply those two fractions together, you multiply the tops, so you get a negative cosine squared. Multiply the bottoms, you get sine. Well, here, we're now going to have to go ahead and subtract these functions. However, to subtract them, we've got to have a common denominator. So for our sine function right here, which is really over 1, you got to multiply the bottom by a sine of x, so therefore you got to multiply the top by the sine of x. So we still have our first part here. It's going to be over sine, so we can write it as one fraction. Then our sine times our sine is sine squared. We're trying to go ahead and simplify this whole left side down so it looks like the right side. We're getting closer. You notice on top these are both negatives, so let's pull out that negative. When we pull out the negative, it's a cosine squared plus a sine squared. I'm hoping you remember that the cosine squared plus sine squared is really your Pythagorean theorem identity of 1, so it's really just a negative times a 1 on top over your sine, so it's really the reciprocal sign. The reciprocal sign is your cosecant. Okay, when we're looking at these, if we're not dealing with an asymptote occurring right here at where we're looking at, then we could actually just plug it in. Here we're looking at what happens with your cosine as you approach x being 0 from the right-hand side. Here's your cosine graph. Approach x being 0 from the right-hand side, we approach a 1, height of 1 on our graph. Here you're approaching negative pi over 3 from the left side. Pretty much you can just plug it in because there's no asymptotes there. And the cosine of negative pi over 3 is the same thing as the cosine of pi over 3, which you should really know off the top of your head, which is a half. We're now going to look at tangent. What happens as we approach tangent from the right-hand side of 0? Here's your x being 0. You come from the right-hand side. Your tangent approaches a height of 0. Here we're approaching negative pi over 2, but from the left-hand side. Your negative pi over 2 is right here. We're approaching from the left-hand side, so that means we'd have to have another one of these graphs just to the left of it. You'll notice as we approach negative pi over 2 from the left-hand side, it starts to go up forever by that vertical asymptote. So it would diverge to positive infinity. Here we want to look at what happens as we approach secant, or approach 0 from the right-hand side of our secant. Here's our secant graph. We're approaching, here's your x being 0 from the right-hand side, and we come into a height of 1. Here we're looking at pi over 2 coming from the right-hand side, still dealing with secant. Here's your pi over 2 from the right-hand side. We got to approach this way to this, which when we follow our function, it approaches towards negative infinity.